This next section we're getting into involves vectors. And you've done a lot of vectors so far back in your physics classes, the very basics with vectors. So some of this terminology is going to be review, and especially at the beginning here we're going to look at just review of what you've done before. Magnitude, directions, components, x and y directions, and so forth. So I'm going to go through this first section pretty quickly. Vectors are quantities that have both magnitude and direction. We are going to be measuring two different things, magnitude and direction. Magnitude, how much we've got, direction, the way that that something is going. And they can be represented using a directed line segment. A directed line segment is something that has an endpoint on one end and then a ray that goes out in another direction. And here's how we can represent vectors. This is a picture of a vector where we've got a starting point and a terminal point. Terminal point is the same thing as our ending point. And the way you can see a vector written is this segment right here, PQ, is equal to vector V. And you'll see this little symbol put above the letter indicating a vector, or you might see the vector written sort of like an italics or a cursive look. The magnitude of a vector is the length of the directed line segment denoted by this double absolute value bars. So magnitude is another word for length. Magnitude and length are synonyms. And then finally, we can say vectors are equivalent if and only if they've got the same direction and magnitude. Same direction and magnitude. So we've got to look at two separate pieces. The first thing is we're going to use the distance formula to find the magnitude of the vector. The distance formula is going to give us the length of the vector line, so we'll know how long the vector is. The second thing we'll look at is the slope. The slope is going to give us the direction of the vector. Just as a reminder for those of you who might not remember the distance formula is x2 minus x1 quantity squared plus y2 minus y1 quantity squared, all underneath that square root. So a visual representation of what we're looking at with vectors, let's say I've got vector with the segment AB and CD. I'm going to draw this as best I can. It might not be perfect, but I think you'll get the idea. Those vectors right there are equal. Reason is they've got the same slope, the same rise over run, and they've got the same magnitude or the same length. Now contrast that with this vector. If I call this vector AB and then this one CD, you can see they're not the same length, as AB is longer than CD, and they do not have the same slopes. These actually look like they're perpendicular to each other. So in order to have the magnitudes equal to one another, we need to show that they have the same direction and the same magnitude. Position when we get to the coordinate plane really doesn't matter for this. Same slope, same magnitude. So let V be the vector from 0, 0 to 4, 5, and U be the vector from 2, 3 to 6, 8. We want to show that U equals V. So to do this, we've got two things we've got to do. We've got to find the magnitude, and we've got to find the slope. So let's start with the magnitude of U. We know we've got to use the distance formula, x2 minus x1 quantity squared minus y2 minus y1 quantity squared. So vector U here's got 2, 3, 6, 8. So if I subtract my x values, and then I square them, and then I'll subtract my y values, and I'll square them, I'll get the square root of 41. Do the same thing with vector V. So 4 minus 0 quantity squared, subtracting my x values, 4 and 0 right there. and then we'll add 5 minus 0 quantity squared, and we'll see 16 plus 25 is the square root of 41. So here we've got the same magnitude. So the first part is good, same magnitude. Next thing we need to look at is the slope. So we'll start with the slope of u. Slope we know is our change in y over our change in x, or y2 minus y1 over x2 minus x1. So 8 minus 3 over 6 minus 2, which is going to give us 5/4. And the slope of v is going to be 5 minus 0 over 4 minus 0, which is 5/4. So here we've got the same slope, and since we've got the same magnitude and the same slope, u and v are equal vectors.